time for a quick tutorial on three-wall projection mapping. So basically the idea is that we have our main screen and actually two virtual screens which don't exist, but we can project images to them, and then we can use pixel mapping or image-based lighting so we can derive data from them. So for example, we have a 360 scene. The screen is showing the main part, but then we have a ceiling light and a side light, and those values are coming from the ceiling or the sky of the 360 image, and there's something that's happening on the side of the image. So what we've done is I've done a new setup called stage 3. So you can see that the scene is like this. That's our main screen, and then I just have like these kind of huge-ish panels, which actually don't exist, but they are kind of where they would take the data from. So that's our main screen. Then we have ceiling and something for the vortexes. 400 by 400 pixels, and I have to make it active, so I still have just the main stage. So either make that active or this one active. So this is important when you do a new project. So check out which one is going. So basically, assigning an image now would assign this image to the three walls. Spherical projection, black magic, and a menu that says where do we want to see the frustum, if we want to see the frustum. So basically our main wall is enough. We don't need to see the frustum in the ceiling, or we don't need to see the frustum on the side wall. It will kind of be more effective, and also it processes faster. So let's create this. So first of all, we have this kind of new thing called channel controller, kind of an example of a switcher node. So we can switch which input is what. The switcher node can assign different kind of inputs for also different kinds of displays. Basically, we are not we're using the same display. We have mapped only one display using so-called mosaic system. We have certain amount of pixels, for example, in our LED processor, and we can assign some of them to also our lighting. So this is our main screen, and here are the other ones side by side. And this should actually match the physical layout of the Helios LED processor. And so when we have the switcher input channel controller, uh, we can see, okay, our screens by default are showcasing something. What I need to do is I have here the three screens. So they all just compiled here and kind of like showcase what to display in this final projection. So first of all, this is our LED main screen. So make sure that now that this is the one that we were using projection before, so the equi-rectangular to the wall, and it's linked to the stage manager, and it's linked to the main screen, and it's linked to the shot camera as well. So make sure that these match. So the second one should be the ceiling, and the third one should be the vortexes. So different things going into the different places. For these individually, I would make them larger, or the screens. I'll first do them so that they kind of fit the frame. This will make our life easier when we do pixel mapping. It's a little bit larger, but also it's kind of how the pixel mapping works. Holding down the space key will let you move this around, and Alt key lets you zoom in. So now we have kind of something visible here, the sky is visible here, and something on the side is visible here. So maybe just to project this correctly, so choosing an interesting place, what to show on the screen, and then the camera frustum okay, it should be active, and this is basically now should be kind of showing where our frustum is, what the camera is seeing. So the tracking data is basically coming from here. That behaves in the way it would as it was in the studio. And these ones just show whatever the camera is seeing. So I can also move this around over here. So if I start tilting it, it's kind of picking up certain other places from the 360 image. All right, let's now switch to stage lights. So we have the stage lights set up. So we have our Vortex 8 and Vortex 4, but let's select it here and first of all make it larger so we can see what it's doing. You can see, okay, we have the same error that it's kind of doing very flickery lighting. So let's change the color sampling to something more neutral. And you can see that it's actually checking out the color lighting from uh, from our main screen. And this is not what we want. We want the ceiling light to come from the ceiling input and this side light to come from the side panel. So let's do the ceiling first. So we have the ceiling, and this is assigned to the Vortex 4, this lamp over here. So how I've defined it here is that over here in fixture, color sampling, and input, I can define which of the inputs does this get color from. 0 is the one that is always the visible thing. 1 is the first input, which would be the main screen, and 2 would be the sky over here. And there's some kind of, I don't know if it's an error or mistake of what causes this, but you can see that if I change it to 0, this really respects what is visible here on the screen. The problem, however, is that, okay, 0 means that whatever input is active. So if I change the input active to be my main screen, the ceiling lights would not take the input from the sky anymore. So I really want to use the sky. For some reason, it kind of respects now the whole square of the sky and doesn't take in consideration the crop. So one way to get rid of that is to go back to the sky input, so this one, and just to make sure that the media actually fits the whole frame. Now I go back to the stage lights and I use this light system here. Now it's really respecting the whole light. And if I go out the boundaries, then it's kind of knowing that as well. Okay, let's do the same for the third one. So the input 3, and I have my light, this one, and you can see it's by default, it's the input 0, so whatever is active. If I change the input, it is blue now, and or it's taking the material from here. So I really want the colors to come from input 3. So I say 3 over here. And again, the same error that it's kind of still finding colors, although they don't exist. This is fine. You can work with this. Kind of has to assume that this image will continue. If you want it to be more precise, I think you go back again, the same thing over here, change the third image, go for the framing and go for the white image, and then go back to the stage lights, make sure that the projection node is selected, and now this is kind of respecting uh, what is here in the third scene, but I can see it's not really matching correctly. And again, this is something that if I have input 3 over here, it's different than it's over here. And there's some kind of a collision happening, probably because this camera is in a different position than this camera is. So I've lifted it up 1.5 meters. Basically, this is the, if I zero this out, now the image should be the same. So now it's the same. And if I go to stage lights, again, this has to be active. Now I can see it's picking up the colors from this image. You can see that I have two lamps, and this other one is not really respecting this image. It's coming from the sky, and this one is coming from the side. One more small thing about the color mixer. I realized that we were talking about this vortex is kind of burning out, going really bright. If I turn up the intensity, actually the color grade and animation. You can see the values now here. So if I went and changed those in the mixer to be higher, and I go to the fixture and grain and sampling, you can see the master level is now higher than normal. So if I control click, reset it back to normal, this is actually the default value, and I can dim it down or kind of be in the normal level. So it's reflected over here. The other fixture, the same thing. Fixture master setting, you can see it's clearly like too bright now. So that would be the default values. So if this is kind of too short scale for you, maybe it's better to change those kind of values from here between the master 0 and master 1. Again, over here, holding down the shift key will make this slider go much slower. So you can do kind of a little bit more refined adjustment.